Hi, this is N7.5, Demonstrate an Understanding of Adding and Subtracting Positive Fractions with Mixed Numbers, Like and Unlike Denominators, and you can do this by drawing a picture or using math symbols or whatever you need to do to get your point across. All right, let's look at our first indicator here, estimating sums. So knowing that some fractions, you should know in your head that 2/3 is 0.666 repeating, right? Knowing that mixed numbers, if you have 4.5 plus 6 1/5, you're going to get some number that's bigger than 10, right? So you should be able to estimate very quickly that your whole numbers would add up to 10, and your fraction numbers, 1/2 and 1/5, you could add those as well and have something somewhere in between 10 and 11. Modeling, adding, subtracting positive fractions or mixed numbers using concrete visual representations, recording the process, basically the same thing as they just said up there. Determining the sum, and that means that you're adding, or the difference, that means that you're subtracting, of two positive fractions with like denominators, so where the bottoms of the fractions match, like 2/3 plus 5/3. Okay, we could add those together. When the bottoms match, we can just add straight across 7/3, and then we could reduce, put that back into a mixed fraction form. This one, explaining how common denominators for fractions and or mixed numbers are related. So common denominators are always related via multiplication or division. So one of the misconceptions is that you can add and subtract to get common denominators. That is not true. As one of my students explained this week, that would be considered an infraction. So funny. All right, next one. Explain how a common denominator can help when adding fractions or mixed numbers. Same thing. These two are exactly the same. Determining sums or difference of fractions with unlike denominators. So you'd have to find a denominator that matches for both of them before you can do any adding and subtracting. Simplifying positive fractions or mixed numbers by identifying and dividing off the common factor. So this is just basically reducing. Okay. Explaining some of your own personal strategies, and we'll talk about a few of those in a minute, for adding and subtracting fractions. Solving an actual problem, like a word problem, and explaining how these sums or differences can be represented symbolically. All right, let's get to the good stuff. Okay, before you can do anything with fractions, there's a few things you need to know. If you're going to be finding common denominators and using, multiplying and dividing to reduce at the end or whatever, you need to know your times tables. You could do fractions without knowing your times tables, but it's going to be hard, as Grumpy Cat says here. Okay, you also need to know that there's some rules. If you're going to add and subtract fractions, there's certain things that you need to do. There's like strategies and steps. There's completely different steps for multiplying, and yet again, another whole set of rules for dividing. So you need to know these rules. You need to know how to convert from mixed to improper and vice versa. So mixed would be something like 1.5, and to convert that to an improper fraction, improper means the top is bigger than the bottom, the numerator is bigger than the denominator. So to convert this little fraction that I've got here, you take your whole number, you multiply by the denominator, and then you add the top. Okay. So 1 times 2 is 2, plus 1 is 3, and then you keep the original denominator, so 3/2. You need to have the benchmark fractions memorized, and we talked about the fact that 2/3, we should just know that that's 0.6 repeating, and we should know that 1/3 is 0.3 repeating. We should know that 3/4 is 0.75. You should know some of those benchmark fractions. You need to be able to do BEDMAS, order of operations, because you're going to get problems and story problems and things like that where there's more than one task at hand. Another prerequisite of doing fractions is you need to be able to print neatly, because we're getting kind of into the nitty-gritty here, and doing something like I did up here, it's going to be confusing if you try and shove it all into one little area, so you need to be neat. And lastly, fraction police always demand that your answer is in lowest terms. So at the end of whatever it is you're doing, multiplying, dividing, yada yada, you have to be able to put it into lowest terms again. So lots of different skills involved in doing fractions. And that, Mr. Grumpy Kitty, is why life is so hard. Now, this cat is even more grumpy. All right. What I'm going to show you here is there are more than one way. There is more than one way to do fraction questions. So whatever strategy you find works for you is fine, as long as it actually works. You can't just make your own. So if you're going to add this mixed number, 9.5, plus this mixed number. So the strategy that they've used here is they've taken out the whole numbers and put them right here. So they've taken the 9 and the 5, and they're adding them separately, and they're keeping that all the way down until they get to this step where it shows that you have to combine the two. So this will work just fine. Take your whole numbers out, keep them kind of separate. Take your fractions, put them over here, and then you're not working with great big numbers. If you were to convert 9.5 into an improper fraction, the strategy is multiply here. So 9 times 2 is 18, and then add the top. Plus 1 is 19 over 2. Well, now we're multiplying and finding common denominators with a number like 19. That's kind of hard, right? That's why that cat looks like that. I'm sure he looks like that because somebody gave him a very bad haircut. All right, so back to this here strategy. They've got 1/2 plus 3/4. Well, that's easy. What do we have here? Okay, I see. They've turned 1/2. It's not super clear, but they've turned it into 2/4. Okay, and so when you're converting, you can't just add 1/2 and 3/4 because those pieces are not the same size. A half looks like this, and 3/4 looks like this. So you can't add those two pieces together and say, yeah, we got two pieces, because those two things are not the same size. So to convert this guy into something that has a denominator of 4, all they did was multiply the top and the bottom by 2, and that's where they got that 2/4 from. Make sense? Okay, so now 2 plus 3, they've said is 5. 5/4 is what we've got. 5/4 as an improper, converting to a mixed fraction is 1. This should be 1. 1 1/4, not 1 5/4. Okay, so how they did this was they used a Dave. 5 over 4. Remember that your bottom sticks out. So the 4, the bottom of the fraction, would be on the outside of the Dave. Bottom sticks out. How many times does 4 fit into 5? Well, 1 left over. So remainder 1, original denominator, 1 1/4, which is what they have right there. Okay, so they had to add 14 plus 1. That's what gave them the 15, and they have this 1/4 left over. Okay, so you can do it that way. This is probably the best way if you've got bigger numbers here, to avoid having to multiply something like a 19 over 2. Okay, the other way to do it, we've got down here in the corner for adding 2 1/4 and 3 1/5. We first of all convert 2 times 4. Let me use a red instead. 2 times 4 plus 1 is 5 over 4. And then oh sorry, 2 times 4 is 8, plus 1 is 9, right? That's what they got here. And then they converted the other fraction, 3 and 2/5. Well, 3 times 5 is 15, plus 2 is 17. So now we're adding 9/4 plus 17 over 5. Okay, and they've decided that they want to multiply both of those by 5. And they're going to multiply both of these by 4, and that gives us those common denominators of 20. And then we can add straight across because our bottoms match now. Gives us 113 over 20. And somehow they've reduced this. Remember, the bottom sticks out. How many times does 20 fit into 113? I can tell you it's not exactly 5, so I'm not sure where they got this from. It's a bad example. 2 errors on this screen. Look at how smart we are. We caught them. Okay, does 20 fit into 1? No. Does 20 fit into 11? Nope. Does 20 fit into 113? Yes, 5 times, which would be 100. And then we have 13 left over. Okay, so this should have said 5 is your whole number, 13 is what's left over, original denominator, right there, 20. Okay, so more than one way to skin a cat. Whichever way works for you is fine. There might be certain situations where you want to just add the whole numbers first and then worry about the fractions separately, but then you have to put it all back together at the end. Whereas if you do it this way, you're working with bigger numbers, multiplying to get a 68 or a 45, having to add bigger numbers to get that 113, that's fine, but then you have to reduce in the end. So either way is fine, just depends what you like to do. Okay, so let's try one of these. I think I'm going to add my whole numbers first. So 8 and 4 is 12, plus 18. Okay. Okay, so I'm working with a 30. I'll just keep that off to the side. And then I can look at my fractions. I got a 1/6, I have 7/12, and I have 1/6. Now, I can see right away my denominators don't match, so I can't just add them straight across. But they do have a cool relationship here, and I can keep this guy the same, and I can just change both of my 6th to something over 12. And that's easily done by just quickly multiplying these guys by 2. So that ends up being 2/12. My 7/12 is fine just as is. And then again, I have another times 2 and times 2 to give me 2/12. So now that all my denominators match, I can add them straight across. 2 plus 7 is 9, plus 2 more, 11/12. That doesn't reduce, and so my answer at the end of the day is 30 and 11/12. So that wasn't so bad. Let's try another one. Okay, so we have some fairly big numbers on this. If this is really confusing to you, you can always check your work on something like an online calculator. You can punch in whatever numbers you want, okay, and then it'll give you the exact answer that you're looking for. So in this case, you can see what I did here. I combined these two and put them into my fraction calculator. I left my 25 over 9 just as is. So if you were going to convert these all into improper fractions, you would say, well, 1 times 36 is 36. Add the top, that's 67. Original denominator, 36. Same thing here, 1 times 24 is 24. Add the top, original denominator. 3 times 9, it's 18, plus 7. Original denominator, boom. All right, so let's just leave the middle fraction out of things for just a minute. If I convert this guy to something over 36, that's easy. I can just multiply by 4, multiply by 4. Okay, so 100 over 36 plus 67 over 36, I can do those right now. 167 over 36, and then my middle fraction that I ignored for a minute. Okay, so I've got this chunk all looked after. Okay, so now I'm just, I guess, and this chunk. We combine those two, and now we're adding that center. So 36 and 24, we could probably find some sort of lowest terms thing that would be easier than what I'm going to do, but if you don't have time and you're thinking, I don't know, I've got a calculator, I'm good to go, I'm just going to multiply this side by 24 and this side by 24, and then I'm going to multiply this side by 36 and this side by 36, and I'll deal with these big numbers and I'll just reduce in the end and it will be fine. Okay, so 167 times 24 awesome, and 36 times 24. Okay, and then 29 times 36. Looking good. And our common denominator, we don't need to put that in again. We know it's already 864. So then I can add those two guys real quick. 4008 plus 1044. Okay, so we're dealing with some super big numbers, but if I type this into the calculator, I know that it goes 5 whole times. Okay, because it'll give me 5 point something something something. And then I can use subtraction to figure out what the remainder is, and it actually ends up as 732 over 864. When you go back to use your laws of divisibility, or divisibility rules, you can see that these two numbers are definitely divisible by 4 because the ending numbers are divisible by 4. So you could try that first to try and reduce. 732 divided by 4 is 183. 864 divided by 4 is 216. Okay, and if you use divisibility rules again, you can see that 1 plus 8 is 9, and 3 more is 12. So this is divisible by 3, because 12 is divisible by 3. Same thing with your denominator. 2 plus 1 is 3, plus 6 is 9. So this guy is definitely divisible by 3. So we'll try that. And you end up with, I think, the grand total. Remember, our 5 is our whole number. Don't forget him. And then when you divide those two fractions by 3, you end up with 61 over 72. So a little bit of work, but it's doable. And so maybe in this case, it would have been better to separate out our whole numbers. 1 plus 1 plus 3 gives us that whole number of 5. And then work through the fractions just on their own without the whole numbers in there. All right. Best of luck with adding fractions. Don't forget, you need a common denominator, and to get that common denominator, you might have to go through steps that give you some big old numbers, but it's doable.